Yeah. Like already, actually, Papa called in and already informed they have reached. Yet we will call him and ask once again. Class, only 7 of you have joined so far. It's already 12:09. So please ask your friends to join ASAP. It's a numerical. You need to understand 10-15 mark question comes. If a question is framed on this problem, then it will be for 10 to 15 marks. So please ask your friends to join ASAP. वहाँ से एसी का रिमोट देते. Thank you. Good morning, class. Am I audible and is my voice clear? Is it breaking? Good morning, class. Am I audible?
Good morning, ma'am.
Good morning. Okay. So is the screen that I've shared clear to you guys?
Yes, ma'am.
Okay. So let's start with today's lecture. Okay. Okay. So but before we start with today's lecture, do you have any queries from the previous lecture? Any question, any doubt, anything that you would want me to explain once again?
No, ma'am.
मीरा मीरा दरवाजा से बता दूँ. Okay. So in the last lecture, we were discussing about I think deadlock. Okay. So we found that deadlock is a condition wherein our system enters into a mode from where we are not able to come out. It is like a lock without any key. Okay. So that is called as your deadlock. So we then explored that in any given system that we have today, deadlock will occur if there are four necessary conditions. Okay. So deadlock will definitely occur if it meets four conditions. Okay, it has four conditions, and if all these four conditions share this resource, that means one process at a time can only have this resource, and that is called as your mutual exclusion. And if this condition is there, second, hold and wait. Okay, hold and wait. That means each processes are holding some resources and they are waiting for some other resources is called hold and wait. Okay. Third, while they are waiting for some other resources, if they are not performing any previous resource is with P4. Okay. And that is if the waiting is in this file. Okay, no preemption and your circular wait. Okay, all these four conditions, if it occurs simultaneously, then your system will enter into your deadlock. Okay, so how do we handle that? How do we prevent then? If these are the four conditions that may lead to the deadlock of a system, then how can we prevent the system from entering into deadlock? Okay, the simple thing is we make sure that one of these necessary condition never occurs. Okay, so when we explored that, we saw that we cannot manipulate mutual exclusion. We cannot make sure that mutual exclusion never occurs because of the critical section problem, because there are applications wherein a resource cannot be shared, for example like banking system. Okay, then we discussed how can we deal with hold and wait, how can we deal with no preemption, how can we break the circular wait. Circular wait may, how did we try to break it? To each resource we assign some numerals, and when a process requests for some resource, you check if the requested resource is greater than the resource that it currently holds. If it's not greater and if it's smaller, we don't assign it. That means we only go from smaller to the bigger. We do not come back. Okay, the backtracking is not possible, so it is only one way going. That means no circle of weight will be created. Okay, hold and preemption is whatever it has, it will release it when it enters into the waiting. Similarly, in hold and wait, when it has holded something, we cannot make it wait. Okay, and if it wants to wait, it will have to preempt all the resources that it has. So we can make sure that one of these three conditions never occur. If we make sure of that, then we can prevent deadlock from happening. Okay, after that we studied how do we after that we studied your deadlock. deadlock avoidance. Okay, so how do we now, if deadlock happens, then how do we, or if we want to avoid deadlock from happening, we do not want our system to enter into deadlock, then what do we do? Okay, so if we want to that, we have to make sure that the system enters into a safe state. Okay, so what is the safe state? Safe state is finding the sequence of execution of processes. If I have like process p0, p1, p2, p3 and p4, if I have 5 processes currently executing or currently in my main memory, okay, if these are the 5 processes in my main memory, then safe state is finding the sequence of execution of these processes in such a way that when we execute them one by one, this system will not enter into deadlock. So finding that state is called as your safe state. If we execute p0 and then p1 and then p2 and then p3 and then p4, if we do this, and if our system enters into deadlock while doing this, then the state will not be called a safe state. Now if we execute p0, then p4, and then come back to p1, and then we go from p1 to p2, and then from p2 to p3, and if after executing the processes in such a way, all of them gets the resources and all of them can complete their task, that means now this sequence of execution p0 and then executing p4 and then executing p1 and then executing p2 and then p3, now this is the safe state. That means all of them gets to complete their task. That means all of the process gets to successfully terminate, and also this order of execution does not leads to deadlock. This is called as your safe state. Now we can avoid deadlock by making sure our system enters into safe state. We can make sure of this by 2 ways. Okay, we can make sure of this by 2 ways. One way is your resource allocation graph that we have already seen. This is one of the very efficient way of allocating resources to the processes that requests it. Okay, another is by using an algorithm that we will see today. So resource allocation graph that we discussed yesterday, okay, is very efficient, but there is one small problem with resource allocation graph. That is, when the number of resources increases, number of processes increases, and most importantly, if there is particular resource one, and this resource one has various instances. For example, if the resource is printer and it has 10 instances, that means if it has 10 printers in the network, okay, then reassigning, for example, now if this is with, let us say, process p1, p1, p2, p3. Now if they are terminated, now new processes enters, so they have one in the graph, they have an association link, right? So now reassigning this, closing it, reassigning it to a new process, finding it a place, assigning address to it, everything incurs a huge cost. And also when the number of instances is more than one, the graph becomes complex and may lead to some form of error. In such case, when the number of instances of each resource increases, our resource allocation graph becomes insufficient. Inefficient. Okay. So in such a case, when we have multiple copies of a resource and our resource allocation graph is inefficient, then we go for the algorithm to avoid deadlock from happening. Okay. The name of the algorithm is your Banker's algorithm. It is called as Banker's algorithm because it can also be used in the banks. Okay. For example, one user can have multiple copies of a resource. For example, let us consider Rijwana. Rijwana works somewhere, let us say, and she has opened one salary account in the bank. Now, along with salary account, after some time, she ended up opening one savings account. After that, she want to buy a car. She applies for a car loan, so she has a car loan. After some time, she wants to build a house, so she goes and takes house loan from the bank. Okay, so she now has four resources. Okay, so she now has acquired four resources of the bank. Okay, but now if she has online banking. Now one person can have, no matter how many account you will open, even if it's just a savings bank account in one bank. If you will open more than one account, whether it's two savings account, one savings, one loan, one salary, etc., etc., only one customer ID will be given to you. Okay, only one customer ID will be given to you, and you will have some balance in your account. So when you will do transaction from multiple ways, it has to make sure that whatever is your current balance is always lesser than or equal to the transactions that you are doing. Okay, it cannot be greater. So because this banker's algorithm has its application and its idea equates the idea how a banking system functions, it is called as your banker's algorithm. It is applicable in it is used to avoid deadlock. Okay, wherein we have more than one instance of same resource. Okay, let us say resource one has more than one instance. If each resource type has only one instances, then resource allocation graph is the best way to find the safe state or to avoid deadlock from happening. Okay, so this is what we are going to study. After studying deadlock avoidance, we also studied recovery. Okay, deadlock recovery. So to recover from deadlock, there are three ways. Okay, to recover from deadlock, there are three ways. Okay, one way is when a detection algorithm determines that the deadlock exists, there are several ways to handle it. One possibility is you inform the operator. Okay, you inform the operator, and the operator will handle the deadlock manually. Okay, some manual actions will be taken. For example, shutdown of the system, restart of the system, or closing the current system, anything like that. Okay, so handling it manually. Okay, so the other possibility is to let it handle automatically, to see how the system reacts on its own. Okay, the third way is to abort the currently running process. Okay, to abort the process that is leading you to deadlock situation. Okay, so now if we do not know which system is leading us to that to handle this aborting situation, deadlock recovery gives you the first step, that is your termination of termination. So this process, before you perform process termination, you have to answer certain queries. Okay, there are certain steps you have to follow that we have already discussed before. So the second thing that you can recover, if now your system has entered into deadlock, so what do? You terminate the process. Okay, there are various steps to it, we have discussed it. The second is resource preemption. Okay, the second is resource preemption. For that, you'll have to select a victim. How do you select a victim and all that we have already discussed. Okay, you can roll back, you can select a victim, but you have to make sure starvation does not occur. Okay, so this is what we have discussed in the last lecture. Okay, so from deadlock avoidance, today we are going to discuss banker's algorithm. Now I've already explained deadlock avoidance, the two methods, and what is banker's algorithm, why is it given the name banker's algorithm. Do you have any doubt? from what is it, the definition, this and that. If no, I would like to proceed. Okay, so write down if everything is clear. Write down in the chat box clear. Thank you, everyone. So now I hope you are ready with a pen and paper. Okay. So now here I've shared my screen here. Okay, just before this, when I was explaining you or giving you the summary of everything, I was also writing in my paint. Okay, I was while doing the summary, I was explaining everything by writing on the paint. Was paint visible to you guys?
No, ma'am.
No,
You
ma'am.
guys didn't inform me. Right now only I realized it was not only that word was shared. The paint was not shared, and I explained everything and I finished. आप लोगों ने inform नहीं किया कि मैम नहीं दिख रहा है. Right now only when I came back to my Google Meet video, I realized it. मुझे पता नहीं चलता है जब मैं वहाँ पे जाती हूँ. When I go back to the screen that I have shared and teaching, I cannot see कि दिख रहा है नहीं दिख रहा है. आप चैट में क्या लिख रहे हो मुझे कुछ नहीं दिखता, मुझे सिर्फ वो स्क्रीन दिखता है. You have to tell me. मैंने इतना मेहनत कर करके सब लिखा. Anyways, the summary is done and you have shared everything is clear. So now I have shared the Word file. Now, right now, just now, the Word आपको दिख रहा है?
Yes, ma'am.
Yes,
मैंने
ma'am.
आप okay. Now consider this snapshot of a system. Okay, so let us consider this is my system only, and this is the current scenario of my system. Let us say that I have currently these many processes running: my Word file, my Google Meet, my Paint, in my background, some displays working. Okay, so I have opened some file. So I have 5 processes running. Okay, so now these 5 processes are allocated some resources. Okay, so let's say all of these, I have 3 resources in my system. Let us say resource A, B, C. Okay, so I have resource A, B, C. So now I have 5 processes currently working in my system, and I have 3 resources in my system. Okay, so let us say this is keyboard, this is mouse, this is my CPU, anything. Okay, so that means now these processes may be allocated these resources, but what is the question is what are the resources that they need. Okay, so let us say process P1 does not need. Okay, so process P1 is allocated, okay, is allocated 0 resources of A का. Okay, A resources 0 allocate किया है P1 को, and from the resource type B, none of the resource type B has been allocated to P1, and again none of the resources only one copy of resource C has been allocated to P1. Similarly, P2, okay, for P2, two, two two copies of resource A is allocated, 0 copy of resource B is allocated, 0 copy of resource C is allocated. For P3, let us say if this is keyboard, okay, so 3 keyboards are allocated to process P3, 0 scanner is allocated to P3, and 2 printers is allocated to P3. Okay, so allocation shows that how many resources are allocated to these many processes. Okay, that is what it shows. So now maximum, what does maximum shows is, now it has zero copy of A resource, zero copy of B resource, and one copy of C resource. That is your allocation. Right now P1 has acquired, okay, these many resources. Now maximum shows that it needs 7 copies of A resource. P1 right now needs 7 copies of A resource to complete its task. Okay, so that means if I want my process P1 to finish its execution, then I must allocate to it 7 times or 7 copy. Okay, या तो 7 बार, अभी फिर थोड़ी देर में एक बार, like it needs keyboard right now, after 1 minute it needs keyboard again, after 2 minutes it needs keyboard again, like that. Okay, I can give, or 7 different keyboards I can assign to it so that it can finish its task. Okay, or I can give it 7 minutes of the resource. So now let's say it needs 7 minutes of A resource, 5 minutes of B resource, 3 minutes of C resource for it to complete its task. Okay, now P2 has so far been allocated 2 minutes of resource A, 0 minutes of resource B, and 0 minutes of resource C. So it is still has not completed its task. It's still there in the main memory. Okay, it has been currently been swapped out. So if I want it to complete its task, I should assign it 3 more minutes of resource A, 2 more minutes of resource B, and 2 more minutes of resource C. If I allocate this many time, these many resources to P2, then it will successfully execute and terminate successfully. Okay, so this is what allocation and maximum means. Okay, so now what are we given is how many of these resources or how many minutes is left for the currently available resources. Now resource A is right now available only for 3 minutes. Okay, resource A is available only for 3 minutes. Resource B is available again only for 3 minutes. Okay, and resource C is currently available only for 2 more minutes right now. So these are the availability of the resources right now. Okay, so now we have been asked, okay, the question is find the total number. यहाँ पे क्या करना है? We will have to find, the question here now is, okay, so now what do I have to find is, the question here is, will deadlock occur during the successful execution of all the process? Okay, the question is, see here I have 5 processes. Now P1 itself needs 7 copy of A, 5 copy of B, 3 copy of C, or time, whatever you would like to say. Okay, but now I have with me, or the system only has now 3 minutes of resource A, 3 minutes of resource B, and 2 minutes of resource C. So if I will assign these many to P1, immediately my system will enter into deadlock because it needs 332. Okay, sorry, it needs 753, but right now we have only 332 available. See here, 3 matlab 7 hai, so obviously it needs 4. If I'll assign all the 3, it yet needs 2 more. If I'll assign 2 for, then for C it's sufficient. Okay, then the system will enter into deadlock. So we will have to find a safe state. Safe state means we will have to find the execution of the sequence of execution of the processes in such a way that all the processes will also execute and also successfully terminate. The execution need not necessarily be in the order P1, P2, P3, P4, P5, because if we will do so, then we will definitely enter into unsafe state. That means our system will enter into deadlock. So we have to choose which process should execute first. Okay, so if it terminates, then it will free all the resources it has. For example, if I'll take process P2 here, see here, if I'll take process P2, it only needs 3 minutes of A. So 3 minutes if A is available. It needs 2 minutes of B. Okay, I have available 3 minutes of B, so I will still have 1 minute extra. It needs 2 minutes of C, and it has 2 minutes of C. So instead of P1, if the operating system allows P2 to execute before P1, okay, then P2 can complete its task without entering into deadlock. Okay, and also after it terminates, okay, after it terminates, see here, it has acquired, इसने कितना लिखे रखा था अपने पास, it has hold 200, and it is waiting for 322. Now 322 is available here, 333 is available, I need only 322. So now if I'll assign 332 to P2, now P2 will complete its task. After completing its task, P2 will also preempt resource 200. So when P2 will complete its task, it will release 2 minutes of resource A or 2 copies of resource A, and I'll end up having, see here, 5, because I had available 3. P2 completed its task, so it released 2 copy of the resources that it had. So I will now have 3 plus 2, 5 copies of A available, because it is 00. So B will remain 3 and C will remain 2. Okay, so now my available resources has increased. Now because it is 532, I can choose this one. See here, 422. So now if I'll allow P4 to execute now, after P2, if I'll allow P4 to execute again, because now I have 532, it needs only 422, so it will successfully terminate. Sorry, yeah, it will successfully complete the execution and also not enter into deadlock. After it has hold 2 copies of A, 1 copy of B, and 1 copy of C, and it was waiting for 4 copy of A, 2 copy of B, and 2 copy of C. So after I'll give these to process P4, it will complete its task, and also it will release the 2 copy of resource A, 1 copy of resource B, 1 copy of resource C. So this way of finding the sequence of processes, okay, is your banker's algorithm. Okay, so now your banker algorithm is made up of two algorithms. Okay, your banker algorithm comprises of, three algorithm. First steps asks what is the available resources that it has. So the operating system, when the various processes are submitted, the operating system will has to first make a table ready with the set of resources it has and how many copies of resources it has. So it will have to run one available algorithm. This available algorithm will find the list of all the resources that are available, and then, okay, every time a process is submitted, okay, so it will have to ask from the processes how many resources it has with it. That means how many resources it has hold right now. So P1 will say I have 0 copies of A, 0 copies of B, and 1 copy of C. So you'll have to run the allocation algorithm, wherein you will ask a question and P1 will have to submit all the resource related information it has. Then you will have to run ask the maximum question. That means the operating system will ask P1, okay, before execution, now how many minutes do you need to finish your task, to terminate your task. So it will have to submit these request later. I need these many. Okay, so after that, okay, there are 2 algorithms that will run. One is the safety algorithm, Okay, that means the algorithm wherein we have to find this sequence. You'll have to write this program, then you'll have to find. You can check in your book the safety algorithm on your own. Okay, numerical में तो मैं बता रही हूँ. So here you'll have to check the safety algorithm. First you'll have to search. Okay, wherein you'll have to constantly compare. Okay, you'll have to constantly compare with the allocation, the maximum, and the available. Okay, what is the initially you'll have to search one by one. You'll have to compare maximum if it is less than equal to available. If your maximum in the code, you'll have to write if max is less than equals to available, then go inside your if block. Else, okay, else go to next block. You will compare again. If p2 less than equal to p2 का जो ये maximum है less than equal to available. If yes, go inside block. Else go to p3, like that. Okay, so that's safety algorithm. You can study on your own. Okay, मैं यहाँ पे आपको numerical सिखा रही हूँ. So after this, the question here that may be asked in the exam is question 2. Is the system in safe state? Is the system in safe state? Okay, so if your system is in safe state, then your system will not enter into deadlock. Okay, so if you'll have to now find a safe state is finding the sequence of execution like p2, then p4, and then we'll have to find next. Okay, so is your system in your safe state? We'll have to find that. Okay, the next question is, okay, so this is what is your banker's algorithm, and this is the problem related to your banker's algorithm. Is the question clear? Is the banker's algorithm clear? Is your safety algorithm clear? Do you have any doubt from this question? If no, first in the chat box write down yes or no. Is the question clear? Class, is the question clear? Thank you, Ram. Okay, so have you noted down this question in your copies? आपने ये question लिख लिया copy में? Unmute your mic and answer quickly. Ram ने लिख लिया होगा. Others?
Yes, ma'am.
Yes, ma'am.
Okay, so can I move towards solving the problem now?
Yes, ma'am.
Yes, ma'am.
Okay. We call this now matrix as need matrix. Okay, so the first step towards your problem solving using Banker's algorithm is finding the need matrix. Finding the need matrix. Okay, so this one is also one algorithm. There are two algorithms for Banker's algorithm. Banker algorithm has a collection comprises of two algorithms. One is the need matrix, another is your दूसरा क्या बोला था मैंने, one is the need matrix and the other we call it as safety algorithm. Okay, the safety algorithm is comparing and finding the safe state. The need matrix is calculating how much does it need. Okay, so I have here, this one was not there. Okay, so this is the question that was given. So from this question, we have copied it again. And to find the need matrix, we have created a need matrix here. Okay, so how do we find need matrix? Need matrix is simple. Need matrix tells that for P1 to complete, how much resources does it need now? Okay, so that is your need matrix. Simple. इसको P1 को कंप्लीट करने के लिए, टास्क को कंप्लीट करने के लिए इसको कितना चाहिए अभी. ओके, सो लेट्स सी. Now P1 has 0 copies of A. Okay, P1 has hold 0 copies of A and it needs 7 copies of A. So that means how many more it needs? 7 only. Okay, so P1 again has 0 copies of B. Okay, and it needs 5 copies of B. So I perform 5 minus 0. So how much does it need? It needs 5 more. Okay, so now P1 has 1 copy of C and P1 needs 3 copy of C. So P1 को 3 चाहिए था, 3 में से 1 it has already been allocated. So 3 minus 1 is your 2. So it needs now 2 copies of C to complete its task. Okay, so this is how we calculate the need matrix. Is it clear? देख लो अच्छे से. Sorry, this is one. I'll write exact problem that I have solved so that at the end I can verify your answers without having to calculate again. I'll give some numbers to this one so that it becomes easier for you. So let me write down for allocation. So let me write down here A. Okay, tab. Let me write down here B. Tab. Tab. So let me write down this is C, and then I will have C equals to available. It means maximum of B minus A. If I'll perform B minus A, now this is your need matrix. Okay, so before you assign this one, you will have to run the need matrix algorithm. What does the need matrix algorithm says? First, compare. If you have, this is RJ. Okay, compare if RJ is smaller than equals to allocation. Okay, if yes, sorry. If yes, call the need matrix algorithm, wherein in need matrix algorithm you will perform B minus A. So 7 minus 0 is 7. Okay, 5 minus 1 is 4, and 3 minus 0 is 3. That means P1 had 0 copies of A, 1 copy of B, 0 copy of C, and now to complete its task, for it to complete its task, it needed 7. Okay, it needed 7, it had none. So 7 minus 0, it still needs 7 instances of A. Okay, so it has hold, P1 has hold 1 copy of B, but the maximum that it needs is, the maximum it needed to complete its task was your 5. Out of 5, it has already hold 1 copy of B. So how many does it need now? 5 minus 1. So it is giving me 4. That means for it to complete its task, it needs 4 copy. Okay. So this is how we calculate need matrix. Is need matrix clear to you all? Class, is calculating need matrix clear to you all?
Yes, ma'am.
Yes,
Okay. So now calculate the need class. Calculate the need matrix for P2, P3, P4, P5. Calculate the need matrix for the rest. Are we done? Okay, so Bhomik, give me the need matrix of P2. Bhomik, give me the need matrix of P2. Bhomik, are you there? Bhomik, are you there? Bhomik, am I audible? Are you there? Chandni, are you there? Chandni?
Ma'am.
Okay, so Chandni, give me the need matrix for P2.
The 1, 2, 2.
Very good. 1, 2, 2. Okay. So thank you, Chandni. Next is Ram. Ram, give me the need matrix for P3. 6, 0, 0. That's correct. Next up we have Rojesh. Rojesh, give me for P4. Rojesh. Rojesh, are you there?
Hello, ma'am.
Rajesh, are you there?
Hello, ma'am.
Shivangi? Shivangi, you there?
Yes, ma'am.
Okay, so Shivangi, give me the need matrix for P4.
Ma'am, 211.
211, that's correct. 211. Okay, so next up we have Subhash. Subhash, give me the need matrix for P5.
Ma'am, 531.
Sorry, how much?
531.
Okay, so 5 tab 3 tab 1. Okay, so this is the need matrix. The first, the question is simple. The question is 5 processes are there in the ready queue in the main memory. They are ready for execution. So when they have come to the main memory, these were the resources that they have hold with them. Okay, so that means I have three kinds of resources in the system. So out of these three resources, P1 has acquired 001 of ABC respectively. But now for it to complete its task, maximum P1 needed. P1 को चाहिए था 753, ऑपरेटिंग सिस्टम ने उसको कितना दिया 001. So if P1 has said to operating system, I need 753 of ABC, and operating system has given 001 of ABC respectively, then how much does P1 needs to complete its task? It's simple. We perform maximum minus the allocated. How much did it needed? That is the maximum, and how much of it has been allocated to P1 by the operating system. Okay, so that is what we did, B minus A, and that is your need matrix. It is the step of algorithm, you can check it. Okay, आपको देख सकते हो need matrix के algorithm. So that is how we have found the need matrix. The purpose of finding it is finding the safe state. So the banker's algorithm, to avoid deadlock, says we have to find safe state. So banker's algorithm says find safe state, then execute your, if your system can enter into safe state, then it will not enter into deadlock. That means by finding the safe state, you may avoid deadlock from occurring. Okay, so the first step of your banker's algorithm is finding the need matrix. Okay, so that is what we have done so far. Okay, so now we will have to find available, or now we'll have to start assigning them or making them execute one by one. Okay, so before that, yes, भौमिक आप बुला रहे थे बीच में? भौमिक, भौमिक, are you there? Okay, so Bhumik, because I had called you several number of times and you were not responding, so I don't know if you have just joined the classes and left for something, having network issues. Okay, so पता नहीं कितने बार आपका network issue होता है. So now just to make me clear कि आप ऐसे ही छोड़ के नहीं जा रहे हो, आप मुझे deadlock explain करो. Unmute your mic and explain deadlock to me. What's a deadlock? What are the necessary conditions for deadlock? Bhumik, unmute your mic and explain the necessary conditions of deadlock. I can see there are some students who are very irregular and not disciplined with their behavior. Okay, I don't think that I do not know that. I'm just being reluctant, or I'm not being so strict because COVID is going on. You are at your places. There are thousands of problems. I'm trying to be considerate and understanding. Okay, so don't go over my head. लॉग इन करके कहीं जाना है तो मत जाओ. like Anita Murmu. She hardly attends any classes. वो हार्डली कोई क्लास आती है. So जब वाइवा होगा उसी के अकॉर्डिंग मार्क्स मिलेगा, जब पेपर चेकिंग होगा उसी के अकॉर्डिंग मार्क्स मिलेगा. जब आप सुनोगे नहीं, आप लिखोगे कैसे, प्रॉब्लम सॉल्व कैसे करोगे. And if there is anything, if I'll ask anything, you have one simple answer, that is network issue. You have got a very nice excuse. Rojes, even I was calling your name. So now it's your turn. Bhomik has shown that he was cheating. He was just showing his attendance. He has just joined the class, but he doesn't listen because it does happen often. I call your names and you guys are not there. And if I ask you anything, network issue. Rojes, unmute your mic and answer with the question, what are the necessary conditions of deadlock?
Ma'am, one is mutual exclusion.
Okay.
Hello. Hello.
Yes, you're
Am
clear.
I audible?
Yes, you're audible.
Yes, ma'am. Ma'am, one is mutual exclusion.
Yes.
Ma'am, in that, ma'am, there is only space for one, just one condition to pass through, ma'am.
Only one condition to
Pass through, ma'am. Ma'am, if there are two conditions, only one of them can pass through.
incorrect. You are incorrect. That's wrong. That's entirely wrong. That's wrong from starting to the end. Mutual exclusion talks about a variable or a resource that cannot be shared. So if the currently running processes needs to access some type of resource that cannot be shared, that is mutual exclusion, and that condition is already there. And in case of mutual exclusion, we cannot manipulate it to prevent deadlock. We will have to leave it like that. It's entirely wrong from starting to the end. लेकिन आपका मुझे उतना इश्यू नहीं है बिकॉज बाकी टाइम पे भी आप सुनते हो, थोड़ा अटेंड करते हो, एंड इट्स डिफिकल्ट टू अंडरस्टैंड फ्रॉम ऑनलाइन क्लासेस एंड ऑल्सो आई अंडरस्टैंड. मैं मुझे आपसे उतना वो नहीं है. बट भौमिक वेयर डू यू स्टे? रोजेश ओके. लेकिन आपको पढ़ना है, आपने बहुत गलत समझा है. भौमिक
Okay.
वेयर डू यू
Okay, ma'am.
just leave it. Those who are not interested, I don't want to spend my energy on them. Those who are interested, keen to learn, I will spend all my energies just on them, no matter if they are strong, weak or average student. I'll give them as much time as they need, not to them who doesn't want to study. Okay, anyway, class. So towards finding a safe state to avoid deadlock, we have Banker's algorithm. The first step towards Banker's algorithm is finding the need matrix. Need matrix is performing maximum minus allocated. That means when a process enters into ready queue, it has to submit to the operating system how many of these resources does it need. So that is a claim that the process makes is your maximum wala portion. Okay, this portion is the resource request that the process has submitted to the operating system, and we name it as maximum. That means it needs 7 A resource, 5 B resource, and 3 C resources. Okay, so now after receiving this request, operating system has assigned to them 0, 1, 0. They have been allocated 0, 1, 0 of these resources. So out of 7, 0 is assigned. That means it needs 7 to complete. Out of 5 requested, 1 is already given. So now 5 minus 1, it needs 4 to complete its task, and the rest. Okay, so I hope you have understood the need matrix. Okay, so we are going towards finding the safe state. Okay, so now we'll have to find the available matrix. So this is your step one. I'm writing step by step. Okay, this is your step one and this is your step two. So now step two is, after you find mid matrix, your step two is to find the available resources. Okay, your step two is to find the available resources. इसको थोड़ा highlight कर देते हैं. Yes, is to find now available resources. So now it needs this one. Okay, it's clear. अरे ये क्या copy कर दिया मैंने? Okay, so okay, we have understood P1 needs 743, but do we have 743? See here, these are the available. So do we have 743? No, we do not have 743. We can, that means operating system right now cannot allow P1 to execute, because P1 says I want 743, but operating system says I have only 332. It's like you're asking from your parent 10,000 rupees at the end of the month, and your parent is saying it's the end of the month, I cannot give you 10,000, I can give you only 2,000. But if your fees is 10,000, can you do with 2,000? No. So what you decide to wait. Okay, so operating system makes P1 wait. So now operating system will check another process in the queue. Okay, so P2. So operating system comes to P2, it checks its need matrix. Okay, so it finds that it needs 1, 2, 2. Okay, operating system finds that it needs only 1, 2, 2. And how much resources does operating system, sorry, how much resources does your system has? Your system has 332. Now you guys unmute your mic and tell me, if P2 needs 1, 2, 2 and operating system has 332, can operating system allow P2 to execute?
Yes, ma'am.
Yes or no? Okay,
Yes,
you can allow. Okay. So now, which process is executing first? P2. So you'll write down here first. Now, which one will execute? Now, first, our P2 will execute. Okay. Our P2 will execute now first. So now, after P2 executes, let's say now at time is equals to 0, operating system allowed P2 to execute. Okay, it allowed. ओहो, हमने स्पेस नहीं बनाया ना P1 के लिए. Okay, so now we are allowing P2 to execute. Okay, so after P2 executes, let's say after 2 minutes P2 is done executing. Okay, so we are moving towards, we are moving towards, let's say, P2. Okay, so after P2 executes, how many resources will be free? See here, P2 को allocated the maximum. If P2 needed 1 to 2, okay, so P2 को 1 to 2 दिया गया. So let's consider it has now completed its task. So after 1 to 2, P2 will release this resource. Okay, P2 will release this resource. It has hold 200. See here, when P2 needed 1 to 2, 1 to out of 332, it was available out of 332. 1 to 2 was given by operating system to P2. So P2 took it, it completed its task, but before it, how many that P2 had? 200. So when it completes it, after P2 completes its task, it will release this resources that it had earlier. Okay, इसके पास जो पहले था, it will release it. So right now, what are the available one? Available is allocation plus available now. Okay, so allocation is 3 and available available was 3 and allocated was 2. So when I do 3 plus 2, I will get here 5. So right now, how many is available? 5. So earlier to this, 3 was available, it had hold 0. So 3 plus 0, I'll have 3 after it finished its task. So now P2 has finished its task. Earlier, operating system had 2 copies of resource 2 and P2 had hold 0 copies. So after it completes its task, it will release the 0 copies. So 0 plus 2, I have 2. Okay, so I have 2. So which one I executed first? I first executed P2. Okay, so now after P2 executes, now how many resources do I have, or how many have you updated? You have updated 5, 3, 2. So right now operating system has 5, 3. Earlier it had 3, 3, 2. P2 completed its task. Okay, so now after P2 completed its task, now I have 5, 3, 2. Okay, so now how this is now done? This one is now done. Okay, so now I remove it. So now I remove it so that आपको समझने में आसानी हो. Okay, so now this is done. Okay, so right now how many resources do I have? Right now I have these many resources, 5, 3, 2. So now can I now let P1 execute? No. Why? Because P1 still needs 5, 4, 3 and I have only 5, 3, 2. Okay, I have only 5, 3, 2. So now P2 is done executing. Now operating system goes to P3. Now it looks at its array value, need matrix. It looks at its need matrix. It needs 600. Okay, so can operating system allow P3 to execute? No. Okay, so it needs 600 and the operating system only has 532. So P3 also cannot execute. So now it goes to P4. It is there in the ready queue. It goes to P4. So P4 needs 211. Okay, 211. So it looks at it's available. It needs 532. So can operating system allow P4? Yes, operating system can now allow P4. So now P4 is given 211. Okay, it needs only 211. इसको सिर्फ 211 चाहिए था, इसको ऑपरेटिंग सिस्टम ने दे दिया 211. So let's say after 4 minutes, P4 is done executing. P4 is done executing. That means after P2, if we do not want our system to enter into deadlock, which is the process that must execute after P2? After P2, it is P4. Okay, after P2, it is P4. So now P4 executes. After P4 has completely executed, now again our available resources increases. Why? Because after P4 terminates, the resources that it had hold earlier, 211, it will release this resource. और जब ये खत्म किया, it comes out. Okay, let's say if it needed 2 printers, now it has been given that 211 printers. So it needed 211 more printers. So it is given now. Okay, so now after it completely successfully completes its task. Okay, so इसके पास जो पहले था वो भी रिलीज कर देगा, जो नया दिया वो भी रिलीज करेगा. Okay, so ये पहले वाला already जो था, now that is not inside this one, so we will have to add it to this one. So now how many will be available with the operating system now? 5 plus 2 is your 7. Okay, so now 3 copies of B was available earlier. Now P4, after completing its task, releases 1 copy of B. So now I will have 4 copies. It had earlier 2. After P4 terminates, it will release 1. So I'll have 2 plus 1 is your 3. Is it clear, class? Class, ये समझ में आया?
Yes, ma'am.
Yes, ma'am.
Okay, so now calculate the rest. Try to find the safe state. Now which process will execute next? What will be the available matrix? Find the available matrix, and also don't forget to write this sequence, because this question here, is the system safe state, इसमें और भी find the safe state करके दे सकते हैं in your competitive exams, okay, or in university exam. Find the safe state. So if they are asking to find the safe state, they are asking about this sequence. That means operating system will allow first P2 to execute, it will allow then P4 to execute, rest you will find. Solve it. हो गया, ठीक है. So which one is the next? P1 is the next. Let me check my answer. No, it says आपका P1 है, मेरा P2, P4, P5. अच्छा यार, ओके, सो हियर थैंक यू. ओके, इसमें एक इंटरेस्टिंग चीज निकल के आया है. सो देयर आर 2 ways you can go from here. क्लास प्लीज पे अटेंशन. ओके, अब आप P4 में पहुंच गए हो. ओके, सो दैट मीन्स the pointer of your, when you implement it, your pointer of your searching has reached here. मैंने जब सॉल्व करके आपको छोड़ा था, it has reached here. Okay, So from here, there are two ways you can move forward. There are two ways you can implement it. Next, you start searching from just the next value of this one. That means you start searching from here, okay? Or you again start searching from the starting one, P1, okay? जब मैंने solve किया, I had ended here, okay? So I left I started from where I had left. So see here, after P4, the updated value was 743. Okay, the available was 743 and P5 needed 531. Okay, so I chose 5 P5 to execute. Now, who answered right now? Who was it? Subhas, was it you?
No, ma'am. Ram.
Ram. Okay. So Ram chose to start searching from the starting point. Okay. So both the ways are correct. आप दोनों कर सकते हो. Okay. So because Ram answered. So Ram gave me. Let's go with Ram. So I have now P1. Okay. Let's see if we enter into safe state from here. P1. Okay. So now after P1, after P1, what are the available RAM? Because now I cannot tally my answer with my answer क्योंकि मैं अब P1 के साथ जा रही हूँ. तो let's see after P1 what will be the available values. Yes, it will be 7 plus 0 7, 4 plus 1 5, correct. 3 plus 0 3, correct. This is the updated value now. Okay, so now let me make it red and remove yellow. Okay, so now this is my available now. Okay, so my sequence operating system now can allow P2. Operating system then can allow. Right now operating system has not allowed. It is just finding the safe state. It is executing the banker's algorithm. It is solving this problem on its own. ये allow क्योंकि allow किया safe state नहीं मिला तो it will enter into deadlock. So it will have to solve it. Operating system will first run banker's algorithm on these processes, find a safe state. If it finds, then it will let these processes execute in this order. Okay. So after P1, which one class? P3. After P1, अब हम P2 में गए. P2 has already executed. That means it is not there in your RAM only. P2 से तो निकल गया. Sorry, P2 has come out of the RAM. So next is P3. Okay. So how much P3 needs? P3 needs 600. Okay. So do we have 600? Yes. 753. Okay. We have 753. So we can allow P3. So what is the next value class?
10 5 5.
Okay, but here I have to write P3, right? I must write first here P3. So now, कितना बोल रहे हो आप? How much?
Ma'am, 10 5 5.
Okay, P3 में से कितना था? 7 and 3, 10. Okay, I think it's correct then. 10, 5 plus 5 plus which one? P3, 0. So 3, okay. Sorry, 5, okay. Correct. This is 3. This is 2, 5. So now this is my current available values. Okay, so these are my currently available values. Okay, so now after P3, I think only one is left now. P5. P5. Okay, so what will be the available right now? Class, give me what is the available now?
10 5 7.
10 tab 5 tab 7. So now if the operating system allows, okay, if the operating system allows this sequence of execution, so okay, so operating system has now found that if this is the order of execution in which I should let this processes execute, and then yes to the question, the answer is the system in safe state. Yeah, because we have found a sequence of order, so yes, it's a safe state. So let us say that P4, like what last one was P5. Okay, so let's say P5 needed somehow, P5 needed last P5 से पहले क्या था P3. So where is P3? P3. This one, no? So I have here P3. Okay, so P3, after P3 successfully executed, the value was 1055. Okay, so now P5, if instead of 000, if P5 needed 10, 6, 7. Okay, if it needed 10, 6, 7. Now my question is, okay, यहाँ पे हमने किया ही नहीं था. So last, what did we get? Right now the available, this one is not there. Okay, this one is not there. So the right now the value is, I have executed P3, P2, P4, P1, P3. Now only P5 is left. Okay, but now the available resources are 10, 5 and 5. Okay, how much does P5 needs to complete? It needs 10, 6 and 7. Okay, so now even after completely assigning all the available resources to P5, P5 cannot complete its task. इसके बाद भी P5 cannot complete. So in this case, we cannot find a safe state. Is the system in a safe state? No. P2 will complete its execution, P4 will complete, P1 will complete, P3 will complete, and finally when we will allow P5 to start its execution, the system will enter into deadlock. So the answer in this case will be no, the system is not in safe state. You will have to write. Okay, so if will deadlock occur, the answer will be yes, deadlock may occur. Okay, you cannot write will, because about systems we cannot be sure, so you'll always have to use the term may. Deadlock may occur. Okay, but now because this is not the situation, so we can end our system in this case enters into safe state. So class, explain to me, is it clear?
Yes,
Okay,
ma'am.
so now there is one way to check your answer. Okay, अब आपका आंसर ढूंढने के लिए कि सही है या नहीं एग्जाम में, you can check. So how can you check? To cross verify your answer, first what you'll have to do is go to your allocation. See here, this is your allocation, this is the chart that was given already. So we have not manipulated allocation, we have not manipulated the maximum matrix and allocation matrix. So what you can do is, from the allocation matrix, perform the summation of this row. How initially, how many copies of A was allocated to different processes? 2 plus 3, 5 plus 2, 7. Okay, 7. And initially when operating system allocated resource B to different processes, how many copies of B was assigned to different processes? We can simply add 1, 2, 2. Okay, so how many copies of C was allocated? 2 plus 1, 3 plus 2, 5. So now I have 5. So when the operating system calculated the total number of allocated values, total of 7 to 5 values were allocated. Okay, so right now after they successfully executed, what are the available value? What are the available? 10, 5, 7. Okay, 10, 5, 7. Now the operating system has got all its resources back. 5 process थे, सबने successfully execute किया, it has got back all its resources. So now the available resources are 10, 5, 7. Okay, and initially after allocating all resources to different processes, the total allocated was 7 to 5. Okay, so now let's see here. इसको थोड़ा एक ही पेज में मैं फिट करने की कोशिश करती हूँ. So to check your answer, available for A equals to Now see here carefully. Now I have with me 10 available after all the processes, returns, all the resources it had consumed. Okay. So what is available from A? 10. What is available from B? 5. Okay. What is available from C now? 7. So I can say that at this moment, your total resources that your system had, आपके system में at all the time अगर मुझे बोलना है तो इसके पास कितने resources थे all together, I can say 10, 5, 7, right? So now A में कितना है 10, B में कितना है 5, C में कितना है 7. Okay. So now initially when it allocated, how many copies of A? How many total copies of A did it allocate it? 7. So if I'll do here 10 minus 7. Now I have 10. Initially, out of 10, how many it had allocated? 7. Okay. So I'll do equals to. Now I have 5 free. Okay, 5 are available now. Initially, out of 5, how many was allocated? 2. Now I have 7 copies of resource C that is available, and initially out of 7, how many total copies were allocated? 5. And to check if your this total allocated is greater than your available, then also your answer is wrong. क्योंकि एंड में फ्री होने के बाद या तो ये बराबर होना चाहिए या तो ये कम होना चाहिए. इनिशियली अलोकेट करने के बाद या तो अवेलेबल एलोकेटेड से बराबर होना चाहिए या तो कम होना चाहिए. लेकिन अगर इफ यू हैव 5 टॉफीज अवेलेबल इज at the starting, if you have 5 toffees and you have distributed 7 toffees, that means your calculation is wrong because you had only 5. अगर आपके पास resource है 10, 5, 7 है and you are allocating 11, 5, 7, then you are wrong. If you have 5 toffees, either you can choose to distribute all 5 or you can choose to distribute only 1, 2, 3, 4. अगर आप बड़ा पूरा डिस्ट्रीब्यूट कर सकते हो तो उससे कम, उससे ज्यादा you can never distribute. Okay, so if this comes greater than this one, your answer is wrong. And also second step of verifying is, now the available is this one. Currently available, after finding safe state, perform the minus of all the allocated. See how much you get. 10 minus 7 is 3, 5 minus 2 is 3, 7 minus 5 is 2. So how much did you get? 3, 3, 2. So now initially after assigning 7 to 5 of resources to all the processes, how many, जब हमने start किया इतना assign करने के बाद how many were available? 3, 3, 2. Check here. See, 3, 3, 2 was available. Okay. So now this is what is given. Sorry, starting में ये नहीं दिया था question में. Only this was given. So these were allocated. When P1 came, OS allocated this much. When P2 came, OS allocated this much. Similarly for P3, P4, P5, it allocated these many. So at the end, we found that in total, these many resources were with operating system, 10, 5, 7. So now in total, if it had 10, 5, 7 and it allocated all of these, the available was this one and that was already given in the question, 3, 3, 2. So after we found the total, okay, total of available and we performed the minus of allocated, we found these were available now, 3, 3, 2. Yes, it's correct because in the question it's already given. So these are the 2 ways you can check your answer if it is correct or not. So this is your safe state. So your answer to your question is the system in safe state. Yes. Find the safe state. Finding the safe state is storing this sequence. So now because there is no deadlock, your operating system will allow the execution of the processes in this order. It will allow first P2, then it will allow P4, then it will allow P1, then it will allow P3, then it will allow P5. All of them will successfully execute and then terminate successfully. Is it clear? The Banker's algorithm? Okay, so this is the end of syllabus. We have completed the syllabus of your operating system. if you have syllabus with you, good. If you don't have it, you can download it from the university's website. You can check the syllabus of your operating system. We have covered each and every topic. कोई भी टॉपिक नहीं छूटा है, हर एक टॉपिक कवर किया है, हर एक टॉपिक का न्यूमेरिकल भी सॉल्व कर दिया है as much as possible. Okay, so with this I declare the end of classes for operating system for this semester. So now if you have any queries, okay, so if you have any queries, you already have my email ID. Okay, still I will write it LCHETTRI Chetri @cus.ac.in is my email ID. Okay, cus.ac, you already have it. Every day you receive link from my email ID. So ये मेरा email ID है, I've written in the paint. Okay, so if you have any queries until 1 or 2 days before exam, you can post, you can email me your queries in this email ID. Okay, टेक्स्ट व्हाट्सएप मत करना, ऑफिशियली ईमेल आईडी में ईमेल करना, मैं आपको एक्सप्लेन कर दूंगी वॉट एवर इज योर डाउट. ओके, so with this we will no more have classes for your operating system theory. You'll have to submit your lab work before your lab sessional. Okay, सारे प्रोग्राम्स एग्जीक्यूट करना है एंड आपको लैब सेशनल के बाद बैंकर्स लैब सेशनल का आपको you'll have to, for lab sessional you'll have to execute the programs till your page replacement algorithm, that is your uh, optimal page replacement algorithm, LRU and FIFO. Then after lab sessional, you'll, for this problem, it will be a compile time problem for bankers algorithm. You'll implement this bankers algorithm for this problem. Okay, and then you'll have to submit it for your final lab file. For lab sessional till memory management, and for final exam you'll also have to solve this bankers algorithm for this particular problem to avoid deadlock. Okay, then you'll compile your final file and then you'll submit me. So with this, your lab your OS lab is completed, your OS theory is completed. So if you have any doubt, you may post your query. If not, then you already know, I think Tuesday you have your lab sessional exam, and on Wednesday you have your theory exam, sessional 3. Okay, so if you have any further queries, you may post your queries. If no, then you may leave the classroom and no more classes from today's. Again, if you have any doubts, you may write down in my you may drop your queries in my email ID. So thank you everyone, thank you for being so participative. Yes.
Ma'am, yesterday I was having network problems, so I couldn't listen properly. Ma'am, on Tuesday we have to submit lab file also.
Yeah, it's exam, so my marks will be assigned to your file. So on Tuesday you'll have to, before examination you'll have to upload your PDF, completely executed program PDF in the Google Classroom, not in my email, in my Google Classroom everyone. Okay, किसी ने ईमेल
Yes,
किया
ma'am.
तो मैं उसको हैंड टू हैंड डिलीट कर दूंगी, और मैं बोलूंगी मुझे मिला ही नहीं. तो आपको गूगल क्लासरूम में करना है, और जैसे ही एग्जाम स्टार्ट होगा मैं आप लोगों से, आपने जहां भी ऑनलाइन एग्जीक्यूट किया है, मैं आप लोगों से लिंक मांगूंगी, या तो आप लिंक भी आपके पीडीएफ में नीचे लिंक डाल देना, पीडीएफ में ही मैं वहां क्लिक करके खुद ही चेक कर लूंगी, ताकि आपको एग्जाम के टाइम में डिस्टर्ब ना हो. Otherwise, it will be you writing your exam, writing your code. Okay, give me your link, give me your link. It will disturb you. So on Tuesday, yes, you'll have to submit your file as well. And how should the file look like? Shivangi, I have explained to your fellow friends. Okay, आप उनसे पूछ लेना. अगर बिना पूछे करोगे तो फिर फाइल में मार्क्स कटेगा, तो आप फ्रेंड से अच्छे से पूछ लेना. मैंने एक्सप्लेन कर दिया है कि फाइल कैसे होना चाहिए. What should be the content of file?
Yes, ma'am.
Okay.
Thank
So,
you, ma'am.
Most welcome. All the best, class. You have been a good student. I had a nice experience. मेरा पहला बार था, तो I did not know if you will participate or not. How will you go? I do not. I have not checked your answer sheet so far, sessional का. So I do not know how well you have written. But a few of you have, as a student, a few of you have been very good, very participating. Okay, so and a few, four or five of you have been like very negligent, very reluctant, and actually थोड़ा सा क्या बोलते हैं, mannerless, indisciplined भी बोल सकते हो. You join and then you don't participate. You just join and you leave, and many of you have very poor attendance. But because it's COVID network issue, I'm not saying anything for the attendance. I just hope you will write well in the exam. Okay, so all the best. Take care of your health and study well. Prepare good notes. If you need any help on any topic, my doors are free. You can always post me, call me, text me. Okay,
Thank you, ma'am.
most welcome. चलो अभी एग्जाम के दिन मिलेंगे. या वाइवा भी होगा, रिटर्न भी होगा. I will give you aim. Okay, you will have to write that code, and in between जैसे ही एग्जाम स्टार्ट होगा मैं वाइवा भी स्टार्ट करूँगी. So I'll call your names and then you'll have to write your viva. Sorry, you'll have to give your viva. ऐसे ही गूगल मीट होगा, लिंक भेजूंगी, आपको प्रॉब्लम्स दूंगी, आप उसको लिखते भी जाओगे, मेरे वाइवा में आंसर भी करते जाओगे. वो ओएस का थ्योरी जो भी पढ़ाया है अभी तक सब पूछा जाएगा. Any further queries? If none, you may please leave the classroom. Thank you.